we're gonna enlarge this, and as you see here, we can set the bases, no, the legs of this blue triangle as 1 as our starting point, and as you see here, it's a 45 45 a 90-degree triangle, but this is 90, and the two legs are the same. So we know this is at square root 2, and we know that this is square root 2, so we have a square right here. And since this is also 1, because it's similar to this blue triangle next to it, adjacent to it, and we know that this is also a 45 45 90-degree triangle. However, the 1 is in a different place, so we know that is square root 2 divided by 2, and square root 2 divided by 2 as well. So if we can easily find the white rectangle. It's just the area of the white rectangle, which is square root 2 divided by 2 multiplied by square root 2, and that's just 1. So we know that the area of the white rectangle is 1, and we have 4 others, so that means it's 1 multiplied by 4 for the total area of the white rectangles. And to find the area of the white squares, we just half it, because we just cut in half, because they are just half of the rectangles. So 1 times 2, which is 2. And we know that because we can just square root 2 divided by 2. So that is just 1/2, and there's 4 of them. So we know the total area of the white regions, which is just 6. And white regions, I want to make sure we label properly so we don't miss out on any information or get confused with our own information. Right regions. So, and also, you might be thinking, well, let's solve for the blue. However, that isn't the best idea, because considering that the blue has so many different triangles, it has more than any other region on the board. So in the square. So we're going to solve for the red. And that's much simpler, as you'll see later, because we already know that the side length of the blue triangle is 1, so we know that the line parallel to this side length is 1 as well, and the length of the other blue triangle is also 1, and we can draw these symmetric lines. So if we draw these symmetric lines, we see that the area of this square is 2 times 2, which is 4. So the red regions is 4. And you might be wondering, then how are you going to find the blue regions? Well, you can use complementary counting, because we know the total area is total area of all the regions is 4 times 4, which is 16. So we know the white regions is 6, total white region is 6, plus the red region is 10. That means there's 6 left over for the blue regions. And we know that because there only is white, red, and blue regions, and they just add up to the total amount. That's how we use complementary counting, and we don't have to solve for all that nonsense for all those small blue triangles, even if it's possible. So we know that the white regions and the blue regions are the same. So if B and W is the same, that means the answer is A. B is equal to W.